Good evening, everybody, friends, ladies, gentlemen. I'm very happy to be here today, especially to introduce Professor Rajkumar Roy, who is head of manufacturing at Cranfield University. Most of us know a lot about American universities and things like that, so you may not be knowing much about Cranfield University, but it is #1 university in UK for postgraduate and PhD studies, and top 5 of the US universities after Oxford, Cambridge, and all, Imperial, and it is ranked top 50 of the world also. And I am particularly happy and fortunate that I had my postgraduate degree from Cranfield University in 1973. And that is the reason why I'm here to introduce our Professor Rajkumar Roy, who of course has joined only last 25 years ago, so were much after I passed out. So Cranfield University is my alma mater. And this year they have honored me very specially as a Distinguished Alumni Award for the year. And that's why I requested, thank you. I requested our Professor Rajkumar Roy Shri to come. I said, now you have declared the award, which I did not know, by the way. It is normally nominated by somebody, then they select and search and whatever. So it was a very pleasant surprise, and then so I requested a professor to come, because I said, you have now declared the award, but do you know what I do? So better come and see whether I'm really a deserving candidate or not. Anyway, that he has to make the comment. So he's here, and today we are visiting our Mamta Group factories, different companies. But I thought I'll take the opportunity here that while he's here, that he must speak on the subject of his expertise, which is the advanced manufacturing and the operational excellence in the digital age which is coming. And Cranfield is at the cutting edge of technology in many fields. Originally, I will not talk too much about Cranfield, which I'm sure Professor will introduce something about Cranfield. But it was originally known as College of Aeronautics. From that, it has graduated to become the university with expertise in aerospace, in manufacturing, in transportation, in energy, and a couple of more things, agro industries. So it is very specialized university with specialized subjects, very small relatively, about 4,500 students and so on. In my time in 73, when I was there, the whole campus, which is away from London about 40 miles, close to Bedford City, near Milton Keynes, those who know England. And we had only we had less than 500 students only on the whole campus. And more than 1,200 faculty and staff. There is a kind of ratio which they still maintain, very high ratio of faculty to staff. So it's a very specialized university with very specialized learning. And that's what I have been fortunate. So I'm very happy to welcome Professor Rajkumar Roy here. I have also spent last 3 days with him at Bangalore, at Indian Institute of Science. Indian Institute of Science, most of you know, that is the #1 premier institute of India. And Cranfield Institute, in collaboration with Indian Institute of Science, has been organizing last 4 or 5 years inclusive manufacturing forum. Inclusive manufacturing. What it means is that how do we, sir, please. You can't sit at the back row. In your class, people can sit in your back row, but not the professor. Come on. Yeah. Professor Ravi Chandran, please welcome. So this inclusive manufacturing forum with IISc experts and many people from other industry, other NGOs, about 45 participants. And the deliberations were about how do we organize the what kind of policies should be there and what kind of approach the industry and the other players should take in order to have manufacturing reaching to the rural areas and how to involve the rural population in manufacturing activities, which is the main job earner actually. The main job creator is manufacturing industry, not the service. And how do we have that value addition reaching to the people? So that is the kind of work which Cranfield University is already doing here. And I was very happy to be party to that because he invited me. Now I will not take too much of your time, and I would like to welcome Professor Rajkumar ji to come and give his talk to us. Please, welcome. Oh, man. I keep forgetting. I already welcomed him 3 days ago, so I will welcome him again.
Thank you, Mr. Patel. And thank you, Prakash ji, organizers of AMA, and ladies and gentlemen. It's a privilege to be here. And I'm so delighted to see all of you are spending your evening coming to listen about operations excellence, about operations challenges in digital era. I'm going to share you my thoughts. I'm going to share you where operations excellence, research, and education is going in the future. I think it's very important we think ahead, and that's something I would like to mention. Some of the work we are doing goes beyond making of parts, making of products. It looks at the entire life cycle of machines, of components, and how do we improve operational efficiency for the entire life. And that's something I'm going to emphasize. I'm also going to share with you some of the observations we have in UK in manufacturing. But before I do that, let me also highlight, give you a little bit more detail about Cranfield University in particular. What we are about, what we believe in, what is the purpose of Cranfield, and in particular when it comes to manufacturing. I lead manufacturing research, education, and industrial partnership of Cranfield University globally. And what is important for me, that we work for industry and we work for people direct. That's what we want to do. And I'm going to mention that through this presentation. Cranfield, it's about creating global leadership in technology and management. So as a university, we are very specialized, and we are exclusively postgraduate. And what it simply means, we start with MSc. We do not have any undergraduate students at Cranfield. But that also gives us real opportunity to work with industry. Cranfield is very keen, very interested to work with colleagues like you, colleagues around the world who are leading industry to support wealth creation. And that's very important for Cranfield. But at the same time, we are looking at technologies which are sustainable, technologies which consume less energy. So well-being of people is very important for us while we are making wealth. I think Mahendraji has already mentioned, Cranfield is #1 in UK in aerospace, engineering, and technology postgraduates. We are 10th in the world when it comes to customized executive education for industry. about 4,500 postgraduate students, 750 doctoral students. And another very important aspect, we are very, very multinational in nature. So 50% of our students come from outside UK. And that's very important for us when we talk about running operations in Greece, to Nigeria, to UK, to Germany. Very different culture. And we encourage students to think globally. And I can see there are many colleagues here who are probably beginning your career. It's important to have global perspective from day one. Because when you become a leader, you may not be running just an Indian company, you may be running a company in UK, America, and China. That global leadership is extremely important, and that's what we do. 80% of our research is world-leading and internationally excellent. A lot of my team's work in manufacturing on operations excellence in research, and we use that to train industry colleagues. In manufacturing, aerospace and mechanical engineering, we are ranked 45th in the world based on 2007 QS ranking. And we are 4th in the UK. Just quickly tell you, Cranfield divides itself into market-facing subject areas, like aerospace, defense and security, energy and power, transport systems, and water. Then we have two areas which are cross-cutting areas. So they work across these subject areas. They are School of Management and manufacturing. In manufacturing, we work in technology and manufacturing management areas. And we work with aerospace, defense, automotive, railways, and defense as well. So we work across sectors. Key features of Cranfield Manufacturing, it's about integration of manufacturing, technology and systems, and material science. This is very important for us. And we develop new management practices. And operations excellence is one example of that. We have been working with Rolls-Royce direct for last 15 years to develop their middle and upper management employees on operations excellence. And I will mention that in a little bit more detail. We work in industrial research and development, technology readiness level 1 to 6. We make machines at prototype level on campus. University has the facility to make machines, not just toy machines. Near industry scale production machines are developed by Cranfield. We have unique facilities. And we have world-class expertise in these areas. These are different technical areas, and we have world-class research and teaching expertise in these areas. What matters to us? Think about through life. Now, if I ask you a simple question, how many of you decided to buy your car based on the cost of the entire life cycle of the car? So if you're keeping the car for 10 years, have you thought about how much money you need to spend to keep that car working and paying for the fuel for 10 years? It's still not very popular. People often just think about what is the current price. But as soon as you buy the car, you commit for next 10 years, 7 years. And that's an engineering challenge. We promote people to think ahead, think whole life. And that is important also for operations. And I'm going to touch on this. We are one of the largest academic team in the country, academic department in the country. And I just want to highlight lab facilities we have, which is significant in industrial, near industry scale. And we have strong industrial partnership. So I'm very used to working with industry. I actually worked with Tata Motors myself before joining academia. My PhD was entirely sponsored by Rolls-Royce. And since then, for last 22 years, I have been working with Rolls-Royce as my collaborator. Same with BAE Systems, Airbus, and automotive sectors. Recently, I've started working with also Bombardier Transportation. That's the kind of partnerships we do. We have long-term partnerships with industry. I mentioned about our MSc program. What we research with industry, we share that experience through our master's program in the main. Sometimes we also have additional knowledge coming from industry directly into our teaching program. So we have regular industrial visitors who has academic credibility and recognized by Cranfield University. They come and teach in our MSc program. We have many such professionals. We integrate industry and academia together. We even have manufacturing directors program globally launched, where colleagues from industry come, middle management who are destined to be directors in the future, they come for their professional development. Very important for us that we work as a thought leader. We organize 2 types of events every year. One is to think about British manufacturing challenges. What are the challenges? What are the national problems? And how can we address that? Every year, national manufacturing debate has become a major event in the country. So I was discussing with some of us here, how about organizing an event, a debate, whether Make in India is actually flourishing manufacturing or not? It's not always, political statement, emotion doesn't always translate into money, into business. There is some gap sometimes, and we need to challenge that. And that's what I do. This year, on 23rd May, which Mahendraji is also going to attend, we are going to challenge British government's industrial policy and ask the same question. Is industrial policy going to help to grow manufacturing in the UK? We also think long-term development of manufacturing. In Manufacturing 2075, we are thinking about how manufacturing is going to change 60 years from now, 50 plus years from now. Think about our lifestyle, how our lifestyle is going to change, and that has direct correlation with manufacturing. So at a glance, when we talk about Cranfield and Cranfield manufacturing, it's about technology and management, and it's about world-class manufacturing research. And the purpose of doing all of this is engineering for life. And that is related to operations excellence, what we want to work in. And I'm going to go into that next. To give you some statistics, UK manufacturing is actually growing and growing faster than economic growth. Economy has come back and it's growing with much smaller percentage than what India is doing, but it is still growing. And manufacturing is growing more than that, 2.5%, 3%. And if you look at the enablers of manufacturing growth, for last 25 years of studies, so we have looked at articles published in newspaper, magazines, and academic journal papers. Domestic demand is one aspect, and export, but also government intervention. In manufacturing in UK, government has started taking more interest after service sector has given so much trouble, including banking sector in United Kingdom. So now there is more recognition in UK that manufacturing is not just an economic activity. It gives stability in the nation. It provides engineering base in the country. Without that, people lose ambition. Without the science base, with the engineering base. That's where we need manufacturing. And there is a lot of hype around Industry 4.0, artificial intelligence, and as you know, this is a marketing term that is coined by actually German government. It's a German government-led initiative. And we often now talk about creating a brand for British manufacturing, which will be the next generation of ideas. Artificial intelligence is also becoming very popular suddenly. You know, many of us have studied artificial intelligence, have degrees in artificial intelligence 30 years ago. It's that established. And science, basic science, has not changed. I'll show you some skill shortages. Top 10 UK manufacturing skill shortages in technical areas: robotics and artificial intelligence, data analysis skills, and that has direct implication on operations. Actually, skill set is in high demand in UK, and we don't have enough people in these areas. Electronic and electrical engineering and software skills. These are serious issues in the country. And when it comes to management, these are the top management skills that's lacking in the country. When it comes to operations excellence, training and education, we are addressing these skills. Now here I want to pause. Operations excellence in UK is developing fast. And it's developing in a new domain. It's changing. We call it servitization of manufacturing. Many of you may have heard. With autonomous vehicles coming in, we will have mobility as a service. And in mobility as a service, you may not be buying cars anymore. You will be paying per hour usage of the car or per unit travel of the car. When the entire responsibility of design, make, and operate stays with the manufacturer. That's what we are going to have. And it has already started, by the way. Even Kalani Group from India went to Cranfield to explore how they could expand into this market, which is a new market for them. We are doing quite a bit of work in this area. Now that has made operations excellence even more important going forward. Because it's not just confined with the production part of the life cycle. it has really expanded into the entire life cycle of the vehicle. And we see this is happening with Rolls-Royce today. 52% of Rolls-Royce civil aircraft engine revenue comes from servitization. 52%. Let me show you that. So Rolls-Royce have power-by-hour total care in engine maintenance. So they often sell, now most of engines are sold based on power-by-hour model. In military, it's availability contracts. And in automotive, we call it mobility as a service, pay as you go, that kind of idea. There are companies available, by the way, in London. There are companies who are providing this service now, today. Let me play you this little video.
Designing, manufacturing and selling a product is increasingly overtaken by the offer of through-life engineering services. Customers of high-value complex products, such as aeroplanes, ships, trains or machine tools, often prefer to pay for their safe and reliable use, rather than for outright ownership. Offering whole-life service support gives manufacturers access to longer-term customer engagement and revenue streams. In future, this model has great potential for household units, such as cars, white goods, and even buildings. Rolls-Royce is a pioneer in this field. Customers of Rolls-Royce engines pay the manufacturer for the use of the engine, whilst ownership lies with a bank or leading company.
All our customers want peace of mind. They want their operations to be predictable, and they want a predictable financial position as well.
Company like Rolls-Royce have 52% of their revenue coming from through-life engineering services.
Through-life engineering services impacts on every stage of a product's life. The products are designed with an added emphasis on reliability and longevity, as well as the ability to incorporate intelligence taken from previous usage to optimize new designs. Individual components of the product may be tagged and sensor systems embedded to enable the capture of specific data. During its use, the manufacturer monitors the performance of the product, ensuring maintenance, repair and replacement are undertaken before failure occurs. The manufacturer may supply regular product upgrades, which improve the product's performance. This extends the product's usable life, whilst reducing its lifetime cost. The intelligence gained from this data helps determine when the product or its parts are ready for disposal. Using sensors and robots can make this process more efficient and sustainable.
It is estimated by our initial research that by 2025, global market would be about £1 trillion. And what I would like to say that through research and development, through education, we actually expand the UK footprint in the global market of tech.
It's about getting people, government, budgets to understand what could be achieved. It's about our academic institutions talking more about this very valuable area for our economy.
Many companies could benefit from implementing through-life engineering services into their business, and they will not need to do it alone.
If we take this model, which I think is an excellent model, and apply it to other sectors, the UK economy will definitely benefit. It's the role of Catapult, it's the role of this group, of this team, to take this concept, to take this idea and translate it into other sectors.
Through-life engineering services presents a huge opportunity for the UK. Increased productivity, increased growth, but more importantly for us, the creation of really high value and highly skilled engineering careers. It's really exciting.
Through-life engineering services create certainty in an uncertain world.
So that's a bit of a marketing style video, but at least it gives you some information what it's all about. So it's about advanced maintenance technology on one hand. It's about changing design so that you can integrate design and service issues together. So design for service better than before. That's very important. you can also improve efficiency of the entire life cycle of these assets. That becomes very important. And that's where we come in, and I'm going to tell you a little bit what we do in that areas. Now, one big change that happens here, ownership of machines like aircraft engines, like machine tools, in this new model can change. And it can remain with the manufacturers. Now, when Rolls-Royce keeps the maintenance responsibility of the aircraft engine with them, that has some implications. In the past, business model very much relied on selling spares. That's actually changing significantly, because now there is a big pressure to have fixed price contracting based on usage. And they maintain maintenance, they offer maintenance, and they guarantee performance. And that guaranteeing performance, think about elevators, lifelong maintenance. But if you have to guarantee 99.99% availability of the elevator, that's a different problem if it is a 95% availability of the elevator. I also even talk to NHS, health service, where they have to provide service which is 100% guaranteed for operational uptime, because otherwise it is serious problem in the operations theater, for example. Cost of doing that is tremendously higher than achieving 95% availability. That's the kind of challenge we are talking about. So it's an engineering problem, but also it is a leadership problem which should address the through life aspects together. So what I'm introducing, and I would like to seek your opinion about through life operations excellence. I think operations excellence needs to really look at the challenge of the entire life and look at productivity not just at the make phase of the life cycle, but in design. In aircraft, it takes about 7 to 10 years to design one civil aircraft or a military aircraft. There is significant issue about design resource you need to make complex machines. We need productivity improvement there. We need productivity improvement in its operations. By the way, 60% of the cost of the life cycle in complex machines are confined at the operation stage. Buying the machine is only 30 to 40%. And that's where the productivity has to improve. And creativity in operations excellence. This is one of my pet topic. People often think about creativity in design, creativity sometimes also in manufacturing processes. But how about creativity in operations? How can we change the way we operate machines, operate equipments? That needs to be upheld. We apply new thinking which is beyond lean manufacturing. So I'll give you one aspect of that. This is a project we had called Lean PPD, Lean Product and Process Development. Here we are really looking at applying lean principles for product development in design. And that's what Cranfield team is very strong. It's not directly my research area, but my team does this work, other professors. And it's value focused. It's not cost driven. And it's based on continuous improvement culture. And the core idea is not to select the final design very early, very quickly. So if you have worked in product development, I'm sure you have used some sort of process, maybe your internal process or other process available in books, where you look at options and identify the best solution you think quickly. But that may not be the best way of doing it. So what set-based concurrent engineering does allows you to have multiple ideas to be researched, to be pursued over a longer period of time, and you evaluate what is good about each of those designs. You combine them together to create new designs, and that improves creativity. And that's one way we are improving productivity at design stage, part of applying operations excellence in design. And that's something I wanted to highlight to yourself. And you can see here, there's a significant difference between point-based and set-based design. If you're designing automotive engine, car engine, for example, look at alternative techniques for longer period. Look at what works for the product you are doing, for the market you are looking at, and combine features. That's what we have done here. So we look at more options, more concepts. And here is an example where we have actually applied at certain parts of aerospace aircraft design, aircraft engine design. And that's the process. So it's very well established. And this is borrowed from lean manufacturing ideas. There are publications you can actually search on the web on lean PPD. You will find papers on this. These are available tools, not rocket science. But what it does, it allows you to explore more designs, more ideas. Like in this particular example, for defining architectures and level of innovation, we looked at intake, combustion chamber, and turbines. And we combined multiple design options. And eventually we put forward 6 key designs over a period of time. And then started integrating some ideas, because not any of those designs are perfect. They have problems. So we wanted to combine features from 6 options and create the final solution. These are done in workshops with experienced designers who can give us these ideas as well. And we have developed processes which you can follow. So you can see here, we started with 2,700 ideas, and we end up pursuing 6 system designs. We did not converge to one quickly. And this is called set-based concurrent engineering. And there are established processes like this. It takes you through the process. In operations, we also apply engineering technology. So we look at in-service degradation assessment. We look at how machines fail over time. So if you want to guarantee performance in your operations, how could you do that if you did not know how your machines actually fail? So operations excellence is not just about process. It's not just about writing a software to implement inventory. It's actually also about technology, which you need to continuously monitor, to continuously model. Model-based engineering of your machines becomes very important. If you really want a step change in operations excellence in digital world, and in digital era, now this is possible. we increasingly have better data, better computing facility to create simulations, and that fits into our operations excellence models. So this is an example we use with something called thermography. We actually inspect life of machines, life of components, and that feeds into our prediction when is the next time the machine is going to break. It's called remaining useful life prediction. We also do some of the work I have seen in Manta Group of Industries, life cycle assessment of electronics into things like environment chamber. So this is more relevant for electronics items. And we monitor through life cost predictions, cost models. I think this is really important. When you are into operations excellence, you want to improve operations excellence or operations management for machines, for assets, you need to have the cost base. And we research on how to develop cost models in a systematic manner. Most of the cost estimates are done by experienced people from their experience. We started 20 years ago, and we brought in some science into it. So now it's much more systematic. If you're interested, please do search on cost engineering and Cranfield. You will see some of our papers in this area in Google. So I am proposing in operations management, to achieve excellence, you need to base your decisions on through life cost rather than just procurement cost. Here is another example of operations excellence. To achieve 99% or beyond availability, we develop technology like self-engineering, machines which can repair itself. You cannot repair and maintain machines manually if you really want to achieve very high level of availability. There must be an element of self-healing. Human being, from that perspective, is a fantastic machine. It repairs itself. Otherwise, you wouldn't survive even a day if the machine stops repairing. And that's what we research. This is an example of work we did in my center with Durham University on electronics self-repair. And now we are extending that into mechanical systems self-repair. There are quite a bit of research on self-healing materials. If a material cracks, especially composites, carbon composites, you can actually fill the crack with resins where you impregnate capsules of resins inside the carbon fibers, well, within the resin of the carbon fibers, carbon-based composites, and it can be triggered to burst when there is a crack. And there are different mechanisms to do that. And that gives you availability going forward. We also use technology like augmented reality to improve efficiency in operations. I'll give you several examples. Maintenance is one where we use augmented reality to support field services, where we can monitor the machine, and from that, we can predict when the next failure will be. And we give instruction how to repair the machine, when to stop the machine, so that you can maximize operational efficiency. That's very important, where we converge our software tools like enterprise resource planning, which is helping us to plan this, but also with technology like condition monitoring. Now, how much of condition monitoring going on in your context, in your business? Anybody want to comment? Yes, please.
We are already doing condition monitoring of our units in terms of vibration analysis temperature analysis, also some of the spatial material conditions in terms of smoothness of surface.
Okay.
Because for our kind of business it is very important that there are sliding moments. All these things we are monitoring, and now we are planning to take it on a internet portal where there will be a platform on which we will be able to generate data and create a kind of predictive instructions to our customers.
Okay, thank you. So that's a very good example how condition monitoring is already used. We use that data to plan inventory. We use that data to plan failure modes and then spare parts planning. That's what we do in operations. Many of you may have heard about digital twins. I think this is really important and this is very important in the digital era. It was not possible a few years ago. In digital twin, you can simulate operations, how this is going to behave, but the details come from your analysis of life of the machine, how the machine is going to behave over time. And those equations are fed into digital twins to give you cost prediction, to give you life prediction, all of that. And that's another area of research we do. And you can see here, health management becomes very important in part of operations. Now, ladies and gentlemen, while we are working in digital era and we use more and more digital tools, have you thought about new problems you are getting or you are going to get in few months, few years' time? And that problem is cyber secure engineering systems. Problem is about cyber threats. In UK, in United States of America, this is a major problem. And I'm afraid it's going to be a problem to you too. And same in China. China is already investing significantly in cybersecurity. It's not just state actors who does cyber hacking. There are lots of technically trained people who breaks into system just for fun. And that has become a major problem for operations going forward. If you're responsible for operations, you want to guarantee performance, and you want to guarantee safety of your customers. How could you do that if your machines can be taken over by people from outside? And this is a serious problem. We have to design machines differently. We have to maintain machines differently than now. Think about your software. This mobile I have, it's reasonably cyber secure. And one of the reasons it is cyber secure, it gets continuous update. You can do that in software. Can you make this one or my laptop hardware cyber secure? Can you really protect my control systems so that the control systems cannot be taken over when you plug into internet as well? That's the kind of questions we are trying to answer for operations excellence. So we teach our operations excellence people on this. So it's very different than many people are taught in traditional operations management. We talk about future challenges, and it's a combination of management practice and technology. And there are many types of threats under cyber. And we are designing hardwares to protect this. And that goes into process development. These are about a machine tool, by the way. How to protect, how to change its control system to protect against cyber threats. Another very important aspect when we are talking about operations is service feedback. How many people actually give feedback from operations to the designers? It is still not practiced enough. Feedback from design, from service to design is a must. if you really want to improve through life operations performance. And we have developed tools to support this across the life cycle. It is based on product life cycle management software. Now let me tell you a little bit about skills side of this. This is a study we did on manufacturing productivity in United Kingdom. We looked at many articles. We talked about productivity over the last 25 years, analyzed them, and these are some of the root causes of low manufacturing productivity. It will be different for India, for Ahmedabad. It will be different. But in UK, skills and education is a major problem. And I can assume that in India we'll have the same issues. Investment, policy, management, quality of management is a big issue in UK. In your small and medium-sized operations, skill of management training is a big issue. From that, we developed an MSc program, entire MSc, dedicated to operations excellence 15 years ago, funded entirely by Rolls-Royce. It's a part-time program, and you can see here, we have graduated about 200 people on this. Middle management of Rolls-Royce come here, those who are high flyers, to become directors in the future in operations. And we now also invite other companies like Weetabix, BAE Systems, Selex, and other companies. Students don't just talk about techniques they learn, they also talk about network they build during this period. We emphasize an operations excellence network in the whole country so that they can talk to each other and improve operations, procedures, and technologies. These are the structures. We have taught elements, but what is important, we have hands-on operational, running operations projects with industry, group and individual projects. And Mahendraji has done this example, this project himself with Aston Martin. And we continue that for the last 30 years. These are the subjects we talk about. Effective factories, business manufacturing strategy, management accounting, human resource management, innovation management, technology management, production planning and control, manufacturing assessment and improvement, and realizing competitive manufacture. So ladies and gentlemen, operations management and operations excellence have to look at wider perspective, both from through life and also bring in the technology, especially how digital era is going to change operations. That's important to understand. And there are business benefits of this. Just quickly mention one thing, bottom line improvement through this master's program. That's what we focus on. And these are the skills which you may be interested, even maybe AMA is interested. If you want to promote operations excellence in the country, these are the kind of experience and skill set you need to develop. Designing, implementing, sustaining change. And that's a continuous, by the way. Leadership to develop and sustain culture of excellence. Lean leadership, and I'm very pleased to see several of you have already used lean, but in manufacturing. Please think about using lean ideas throughout the life cycle, in design, in maintenance. Application of IoT, Industry 4.0 technologies using empowered teams. Essentially, fundamentally, it means serve sensor networks. We have been working, by the way, on sensor network for many, many years. Now it is rebranded as IoT and Industry 4.0, but it has helped us to combine, connect more individual components together. That's the difference. Now we are doing more of it. So the scale has increased. We have more data, much more than we had before. But the technology existed for many years. We are dealing with scale now and creating a discontinuous innovation capability in the organization. So I'm conscious of time. Through life operations excellence is for the future. Going beyond customer demands, delighting the customer using more creativity. And this is something not practiced in operations enough. Seamlessly blended product and service. Think more about supporting the product for its entire life cycle. This is coming. This is already there in UK, in US, and in Europe, and it's going to come to India very soon. And first will be your defense sectors and the new upcoming aerospace sectors. They will be actually requiring that more, along with organizations like elevators. They need service offerings more than many other sectors. Managing connectivity and data to provide competitive advantage through fast response and enhanced customer experience, but also autonomous teams, taking total leadership of delivering excellence to their customers. Learn continuously as an organization. I think that's important. And technology blend with organizational structures that exploit the full potential of both technology and management techniques. Just technology is not enough. Similarly, just management solutions are not good enough. You need to have both. You need to really exploit the technology that's coming up and support that with the leadership and management practices. That's how Cranfield is trying to integrate technology and management together. Ladies and gentlemen, I would like to stop here. Thank you for your patience. And next few minutes, I'll be delighted to answer your questions. Yes, please.
Thank you, Professor Rajkumar. You have given us reopened the new aspect are awaiting in India. People from operation, from the project, they are coming to the IT sector, service sectors. While the core engineering, core manufacturing, and they are giving the best bread to Indian economy. And I am very thankful to you, and so that the people will think this operation and operational excellence is desired in India to increase the GDP. I think the industrialist is sitting here. Nowadays the things are like that in industry. I am from aluminum industry. There are nobody available. We had word after retirement here because the people are not available. People are not coming to the operational things. They are not coming to the maintenance. They are not interested even in projects because they have to face a hard life. They want to go to the service sector, either marketing or IT. So this is really opening a new avenue for the people and the youngsters. Thank you very much.
Thank you. And this is actually a very important point you have just raised. I have experienced that in UK significantly. There is another angle to operations. Many young colleagues, when they are developing their career, they do not find operations very attractive. Whereas design, whereas manufacturing is very attractive because it's creative. They like that creativity. And that's something it's our job to change. Operations can be creative too. We need to improve the working conditions of operations so that they have the space to be creative. I think that's one. Second, we have to bring new technology into operations. Please take the leap into new technology, and that will make it very attractive to next generation of people. And that's actually missing in operations community throughout. It's not just in India's problem, it's problem in UK equally. And we are trying to work in that direction, and that's why Rolls-Royce is so interested in Operations Excellence program with Cranfield. Thank you. Yes, please.
In the operational excellence, what major shift has taken place in last, say, 1 or 2 decades than earlier? Because now we are in the digital era. What major shifts have taken place?
I think major shifts haven't taken place enough. It is still very traditional when it comes to real management of operations in traditional sectors, but it is slowly picking up. So we are doing some research, so as few other universities, and it's becoming slowly popular for future challenges. So one change has happened is improving efficiency in operations using new technologies. Like you can find now technology like augmented reality, like virtual reality is used in operations, in practice. That's already happening, especially in field service sectors, where people go around and maintain many, many machines in different locations. So you can give them instruction through their eyeglass, and they can interact with the machine in terms of historical data stored on that machine. So they can be customized quite quickly. So that's happening already. So that's one area it's happening already. Second area, it's happening in terms of condition monitoring. That's improving. And although I'm not very happy with the kind of effort people are doing at the moment, but it is significantly improved than what it was 10 years ago. So these are the two practical examples which I can say for real it has happened. And lean thinking has moved beyond making, beyond manufacturing process. In our language in UK, we consider design, production, which is making, and support as part of manufacturing. So it's an entire gamut of design, making, which is, I think many of us mentioned just manufacturing to represent making, and service as totally as manufacturing, and that's what British government recognizes. Thank you.
I think this is excellent eye-opener for us. But finally, when it comes to manufacturing or an organization, I think the customer plays a final role. Right? Possibly one area is actively getting our customers involved in the operational excellence. Traditionally, the customer tells the sales tells the design tells operations. Possibly a real-time sort of feedback and adjustment in operations can also be a part.
Very, very good point. And this is something we have already noticed happening already in field service sector, where not only customer, but end user now can give feedback directly to the manufacturer, and design team in the manufacturer is having access to that information direct. So they don't have to go through intermediaries. That's already happening.
Sir, you haven't covered cost aspect of the whole. Maybe cost may be too high, the objective may be very desirable. Cost aspect you have not covered.
Yeah. I have been working in cost engineering for last 20 years. So I did not focus here purely on cost engineering. And I come from engineering perspective. So how much does it cost to make 100,000 of these product? This is a product, how much would it cost? Can you predict this before it is designed? That's the goal. And that's where I started about 20 years ago. Then I worked with Airbus about predicting how much design effort you need to do to design very complex aircraft structures. Can you predict that in advance? The advantage of doing that is then you can do value engineering. You can change parameters to reduce cost. That's how we have done it for real. And third, which we are doing now more and more, is predicting cost of service. So if I'm BAE Systems, I'm signing up a contract for aircraft, military aircraft with MOD, Ministry of Defense. It's 20 years contract. Do we know how much maintenance cost I have to take care of in this period? That's the kind of area. Again, you can see many, many publications on this from my team. So just search cost engineering and Cranfield, you will see that on the web. Please.
Particularly your true life cycle manufacturing has got its own challenges, and I am mentioning to you because we are into project business of machinery, and we guarantee total cost of ownership. I mean, it is similar to the true life cycle manufacturing. And the kind of deviations got big MNCs, because we deal with all big MNCs of the world. They are not sincere, they are not honest in their commitment. For example, they are not willing to buy OEM parts. They develop pirates. Likewise, the biggest beer company of the world has got a pirate parts manufacturing organization in China. And they are manufacturing parts for all kinds of suppliers who are rated to be top class suppliers of that beer company. And if that is the case, then how do we address this through life cycle cost and adhere to the kind of machine uptime? Probably for them, machine uptime is not important.
It's very, very good and practical point. I have experienced this in the United States from counterfeit perspective. This is actually a counterfeit problem. And now it has become even more important because in operations, there is serious threat on safety and security in the country. I will give you a specific example in aerospace and defense sector. That's most of my work in that sector. In US, I attended a conference on counterfeits, and people are saying there is so much cost pressure to maintain the aircrafts. They have no choice but to go into gray market. This is where government have to take a leadership and support long-term partnership with industry to control spare parts, but at the same time, respect original spare parts. And that's not happening enough, by the way. When country is in war, they're going and buy things wherever they can, 1/5, 1/10 of the price. Now that is proved to be extremely difficult when it comes to safety, because there are components bought, and I don't want to mention any country's name, from different countries, which is sending data suddenly to a server abroad. There are softwares embedded in these components. That's one problem, which is a security problem. And these are done by state actors for critical components. There is also technical problem in terms of quality of materials. Fatigue, failure of products. You expect it to survive, let's say 1,000 hours. Suddenly after 200 hours it's failing. It's bringing down the entire asset. And these are real challenges that is happening today. So I totally agree with you. And this is giving problem to manufacturers. Now what manufacturers have to also convince government, it's the protection they bring with the original spare parts, and maybe have a partnership with customers to give them a fair price so that they can afford at the same time. Yeah. Because otherwise government, I had military officers telling me, it's all good for politicians to talk about buying original parts and not buying gray market, but I have to go and do a mission tomorrow in Iraq, and 5 of my aircraft is down. What do I do? Do I get bombed, or do I repair this at any cost? So what they do, they take one aircraft, take parts out of it, and they start repairing this one. That's how they survive in reality, yeah? Or they buy in gray market.
That is always the case with machine or shop floor which is delayed for delivery. It will be ripped off.
And this is happening in real, in practice. Yes, please.
Sir, we talked about the ownership being changed.
Yeah.
Are there responsibilities also attached to it? Will the responsibilities change? If the ownership comes to manufacturer, what are the responsibilities of the users?
Okay. So, very, very good question. In academic terms, we call it co-creation of value. That's important. Co-creation of value means you cannot benefit from the machine just on your own. Your supplier, a manufacturer, cannot just give you the value on a plate. Customer have to play a role. Customer have to know how to use the machine in the first place properly. If they don't get the benefit fully. So that's the simplest example. I work in defense sector where BAE Systems, which is a defense company, would expect Ministry of Defense to take certain responsibility as part of the contract. For example, to provide them with all the relevant tools for the assembly. These are, by the way, not available in the marketplace. So these are specialist tools. It only comes from Ministry of Defense. So they have to provide that. They have to provide testing softwares. It's customer's responsibility. If they fail, the project is delayed and there is penalty. Officially, there is penalty to the customer if they fail to deliver this after signing the contract. But then comes political pressure. It doesn't really always happen because you want to win the next contract. So if you penalize them now, you may lose the contract next. So end of the day, manufacturers end up covering all these costs. So that's the negative side of this. But in commercial world, this is becoming a regular practice now that customer have to take responsibility. And it's part of the contract. It's a co-production. It's a co-value creation. That's what it's called. Gentlemen, back, yes.
Sir, as you talked about that cyber security threats are more common in US and UK countries. But in India, we are also facing the same problem.
Yeah.
Like in the last few days, there was a problem that Aadhaar was also hacked by one UK official. So like we are not having our unique identity. Like if I'm, like for an example, if I'm going to Domino's Pizza, so if I'm giving my phone number, all the details directly came to them. So it's like I'm not having my unique identity or it's my decision to give any of my identity to them. So like the trust of being like for an other is lost in our country. So like how the operation excellence or cybersecurity engineering system will work.
So I don't have complete answer for this. We don't know yet. But some of the technology we are looking at is distributed laser technology. In fintech areas, blockchain is basically distributed laser technology. We are looking at using that as the basis of designing control systems which can be linked to individuals and as an owner of the machine, and that will help us to improve identity of those machines. So that's the kind of technology that will come in the future. We are working with Royal Mint, who has come up with gold assured blockchain, which is slightly different than just using blockchains. So we are working with them to transfer and develop next generation technologies on this.
Sir, I just want to know one point. Your model, this hiring the solution from the manufacturer, it is very well done before for 20 years in India. When cycles was not there and we learned to ride the cycle, that time we are hiring the bicycles on rented basis, and all the responsibility was the seller only. Whatever the damages we are done during the learning, it is also the cost of that will be one. So that model is operational well before, many years before also. Just I want to note that.
Thank you, and yes, but I want to just add a couple of other items. Imagine now you are signing a contract where you are saying give me 10 rupees an hour for rental, and by the way, I guarantee 100% or 99.95% availability of the bike. There'll be no, for example, no puncture of tire, and the chain will function as it should be. That's when the problem starts. And then due to competition, you want to come down from 10 rupees to 6 rupees. That's when the problem starts. That's where the real new challenge brings in. How do you push the cost down in this, and how do you guarantee reliability of the product? And that's the new technical challenge that's coming up. If you had infinite amount of money, no problem.
I think we'll take last question now.
Okay. Gentleman at the back.
Sir, I wanted to know how do you inculcate innovation and creativity at Cranfield? If you can throw some light on this.
Okay. So one of the ways we are looking at encouraging creativity in operations, we have started looking at maintenance as activity and operations of running, for example, aircraft, applying design thinking, which is used very early stage in the product development. Can we apply that into deciding manufacturing operations, decision making in manufacturing operations? Essentially, in very simple terms, what it means, do not close the solutions too quickly. Keep the options open. Allow more options to be evaluated. And then link ideas together to create new solutions for problem solving in operations. That's the kind of way we are applying design thinking into operations to improve creativity. Thank you. Thank you, ladies and gentlemen, once again.
Just a couple of minutes will take. Sure. So the last formality, just to say big thank you to all of you first, and a big thank you to Professor Roy for sharing a lot of insight. I think I had a lot of paradigm shift when I was going through the presentation. So big thank you not on behalf of Ahmedabad Management Association. Sir, on behalf of AMA, a special memory to you. So before you leave the hall, please share your feedback. Okay, and with this big thank you so much.